issues of analytics and transparency are especially important. They're always important in data visualization, but in climate, they're extra important. So very excited to hear these 3 short talks we have, but hopefully we can have a really good conversation around this issue and how we can help build trust around our work. So let's start it off with our first talk on interactive visualization of ensemble data assimilation forecast for freshwater floods by Ameya Patil.
So yeah, good morning, good afternoon, good evening. I'm Ameya Patil. I'm pursuing my PhD in computer science at the University of Washington. And in this talk, I'll be talking about HydroVis, which is our interactive visualization dashboard for ensemble data assimilation forecasts of freshwater floods. So I hope by now we all know why forecasting floods is important. Florida has been going through a lot in the last 2 weeks itself. So that's the motivation basically. I'll jump directly into ensemble data assimilation forecasts. So on a very high level, this is what it means. We have an ensemble or a set of models. In this case, we have the weather research forecasting, hydrology forecasting model, which makes a forecast for the event of choice. In this case, they're forecasting the stream flow, that is the amount of water flowing per unit time in the river system. And because forecasts are not 100% accurate, we also gather real life observations, measure the amount of water flowing per unit time actually in the stream, in the rivers. And we assimilate or combine these 2 different sources of information to get a more refined estimate, also known as analysis. And in this way, we keep repeating this cycle again and again. And this process is not easy to understand or try in general. So what we did was we designed HydroVis. It's a decision support system, basically to visually understand flood forecasts and try flood forecasting models. So what we have here is a screenshot of the river system of Florida during Hurricane Ian in 2022. So we have a map visualization here, which shows the forecast for the stream flow, amount of water flowing per unit time in the geographical context, of course. And it also provides an interface to select 2 segments of choice to view the forecast in more details in the plots below. So the first plot in the bottom left corner here shows the forecast for the stream flow, averaged across all the models in the ensemble, or the river segment chosen from the map visualization. And we also have the option to toggle observation gauge locations, where we can actually gather real life observations, which are shown as red circles in the map here. And we can view those real life observations against the forecast in the plot here. So we have the red marks here, which shows the actual observations. Then we also have a histogram here in the far right corner, which shows the distribution of the outputs of the individual models in the ensemble. This can help weather scientists to try or optimize the model for a specific distribution, and can also help them understand how far from the initialization values have the individual models diverged over time. We also have inflation uncertainty being visualized here. Is basically an artificially applied uncertainty to prevent the system from collapsing to predicting a single value with false confidence. We have that over here. And then there are UI controls. We can change the kind of aggregation we are applying to the visualizations. We have mean, we have standard deviation, and we can also inspect the values of the individual models in the ensemble. Then we have the option to configure the visualization to show different data assimilation phase, forecast, analysis, which is the refined forecast, and the increment, which is difference between the 2 phases. We can also show different inflation values in the dashboard. And finally, we have a time slider to view the forecast at any specific timestamp of choice. That is a very high-level overview of HydroVis. I invite you all to watch the walkthrough video and also go through the short paper on the website. Thank you so much.
Thank you, Ameya. Our next speaker will be Carolina Veiga, Urban Computing for Climate and Environmental Justice. Take it away.
I'll be presenting for Carolina.
Okay.
Right. So, hi everyone. My name is Fabio Miranda. I'm an assistant professor in the Department of Computer Science at UIC. And our paper provides a brief overview of a set of projects that are grounded on the concept of urban computing, which was first formalized back in 2014 in a paper by Zhang and others. And at the core of urban computing is the growth in the availability of data about cities, from sensor data to weather forecasts, and more recently, image data on the built environment. And over the past decade, our team has been proposing tools and methods to analyze this wealth of data to tackle pressing urban problems, from the availability of sunlight access to how weather conditions impact older adults. And particularly in the past 5 years, we have been engaged in a series of research initiatives in both Chicago in the US and Niterói in Brazil. Two cities that are notorious for suffering from climate and environmental justice issues, including heat waves, flooding, landslides, and air pollution. And these interdisciplinary projects have brought together key stakeholders, including visualization and sensing experts, as well as city officials, civil engineers, public health experts, urban planners, and climate scientists, and more importantly, communities. In these collaborations, we have built a series of visual analytics tools for both experts and communities to interact and analyze urban data at scale. So I don't have time to detail these tools. Their references are available in our workshop paper. These tools have been featured in different media outlets and have been used for engagement activities by community residents, both in Brazil, but also in the US. More importantly, these tools and computational frameworks that we have proposed have allowed us to support the collaboration between scientists, communities, and policymakers. Communities and policymakers interacting to increase legitimacy of policy change, scientists and policymakers interacting to support evidence-based policy inputs, and scientists and communities interacting to ground innovative research on actual real-world needs. Despite all of that, however, building these urban computing pipelines that straddle data collection, generation, all the way to visualization, while accounting for the specificities of different scientific domains, is still a challenging task with many unaddressed issues that we highlighted in our paper. Perhaps more importantly is the fact that solutions are still being built in isolation, which leads to the wasted effort trying to replicate or implement methods and tools. To solve some of these challenges, we have been recently awarded by NSF to build Oscar, an open source infrastructure for urban computing. In the near future, we will integrate some of the methods and tools for the exploration of urban data, addressing challenges from data discovery to the visualization and reproducibility, making them available to a broader audience. That's it. Thank you.
Thank you very much, Fabio. And then the final speaker in this session will be Ying, exploring the reproducibility of visualization figures in climate change report.
Hey, can you see my screen?
Yes.
Okay. Hi, everyone. I'm Lu from Zhejiang University, and today I'll present the paper exploring the reproducibility for visualization figures in climate change reports. IPCC is the intergovernmental panel.
Sorry, I think we're having an issue. It seems overly zoomed in. Is everyone seeing that?
Sorry?
Like
What's wrong?
No, it's working fine for me,
It's
Mark.
working okay, Mark.
Is it really only me? Never mind. I'm sorry.
Okay, so I'll move on. IPCC is the intergovernmental panel on climate change, and they have reports every year or every several years. And in each report, there are a lot of figures. And for these figures, actually, it's not very easy for the public to understand. So we want to improve these figures, but we face some challenges because if we want to improve these figures, we need the source code and data to reproduce these figures so that they can be SVG based, not the pixel based one. And we focus on this one specific report. And for this report, actually, IPCC provides a repository on GitHub, and they have some descriptions like the right parts. However, we face a lot of challenges like lack of data, very difficult to set up environment, and sometimes we are very difficult to find the real README file. So we want to create reproducible figures from IPCC data, both for us and for the future researchers to do researches based on these sources. And we do several steps. The first step is set up the environment. We focus on Python file now, and we also preserve the original repository, and we use the submodel to preserve the original one. And for users, what you need to do is just run the download shell, and then the environment can be set. And the second one is prepare the data. The data is usually like from everywhere in the websites. Like you will use a lot of time to find one. So now you just need to run the install.shell file, and then the data will be downloaded. And the third step is patch and run the code. Because some code they cannot just run, so we need to patch the code. And for users, you need to do is just run the run.shell file. And also we provide the README file for these all instructions. And we also provide instructions for future users because these figures from 5-dimension input, running, output, quality, and post-process. You can see from the right part, if you see all green like the figure 4, so congratulations, this figure is exactly the same as the one in the report. But usually there are some orange or red stamps. You can see from this example, like the left one is the source figure, but the right one is the reproduced figures. It's not just one figure, there are several figures. And you need to do the rearrangement, and also like you can see from the legend one, the left one is not the same as the original one, and you also need to add some text, add some lines and find the missed subfigure to be the source figure. This is another example. The left one is the source figure, and the right one, you can see the color are not exactly the same, and also some very small details like the white for the lens, they are not the same. So we want to, in future, we also want to, we realize that the reproduced charts need post-processing, and we also face difficulty in ensuring the identical reproduction, and we also want to enhance the figures for border impacts. The right one, we also, based on the original repository, we also have a website, the GitHub repository for the reproduced figures, and if other people want to do this or use these resources, feel free to scan the QR code to see the repository. And also the left one is my homepage. I'm finding a postdoc. If you are interested in my work, feel free to email me. Thank you.
All right. Thank you very much. So do we have any questions for anyone in the group?
Hi, my question's for Fabio. I wondered if you could share a little more about your target users, particularly. I know you said this is participatory, but who have you potentially done user testing with, or who are your primary users?
That's a great question. So our workshop paper, they covers many research projects and tools. Some of these tools, they have been evaluated by climate experts through case studies and written by them, but also usage scenarios. But some of these tools, they have been used by community residents, though we did not have any evaluation in terms of user testing from the perspective of the community residents.
Can I ask a follow-up about that one? The community ones, particularly that you've had it with or experienced with, how are you finding? Are there any directions for things you're finding that they particularly resonate with, or that they maybe need more scaffolding with? I'm just curious about how it's going with the community members.
Yeah, so it has been quite different than engaging with experts as expected. Because once we attend these community meetings, they mostly rely on papers. So we have to port our visualizations to paper-based visualizations, and then they use these visualizations in order to engage other community residents, right? So there is this spectrum in the complexity of the visualizations that we create. And one of the challenges that we are currently facing is how can we support both the needs from the experts as well as the needs from the community residents without having to, replicate effort, redevelop certain parts of the systems, right? So making sure that the visualizations that we create, the experiences that we create are flexible enough to account throughout this spectrum.
I'd have a question for Lou. So the lack of reproducibility you encountered in your work, was it more due to, let's say, unprecise documentation of the team that put the figures together, or was it due to changes in the software versions, for example?
We have encountered several issues that lead to a lack of reproducibility, including tools not being made publicly available, either through GitHub or other means, right? And that's due to the fact of the challenges of making open source code publicly available, right? Part of these tools, they are research projects that have their own constraints that lead to tools not being made publicly available. And one of the challenges that we are currently trying to tackle right now is how can we provide a cyber infrastructure that facilitates these tools to be made publicly available? How can we lower the barrier to the creation of open tools and open urban computing pipelines?
Thank you.
Michael, was that question to Lou, right?
Yeah, but
Lou, do you want to reply?
Yeah. But can you repeat the question again? I just forgot.
I was wondering, in your work with the IPCC figures, if you was it the problem to have found so few reproducible graphics in the selection? Was it due to the, let's say, not really completed documentation of the guys that developed the visualizations, or did it also have to do with, for example, new software versions that are not completely compatible or something like that?
I think the problem that the figures are not exactly same is because sometimes authors just upload the repository to the let's say managers, and then for some designers they will just update the figure like some detail thing, or actually they need to combine these figures all together to be a new figure. So they use another software to do these things, or sometimes they will update the elements to be like seems good, seems fantastic. Do I understand the questions right?
I think so. Benjamin?
Yes, that's a question also to Lou, General. I guess you have done a lot of work to create these figures and recreate the figures. I don't want to ask how long it took you to go through all of this and rewrite the code. On a high level, do you have any suggestions of what people who create those visualizations and platforms can do to help reproducibility, to make the life easier for people who want to scrutinize things?
I think that's a very good question. I think it's still a very long trip to do this, and I think the first step is a very detailed README thing, because although Because if you use Python, some libraries, they will be outdated, they will change a lot. But if you say everything right and told the later future user that what version you used, and as a future user, I will be very easy to follow your work and find what happened to the Python library also with your code you write. So I think a very detailed README is very essential for reproducibility. And this is the thing that just came to my mind.
Can I follow up on this? Because I see we still have a bit of time in this session.
Yeah.
Opening up the question to the other two talks, what would you think you can do in interactive systems to keep your systems reproducible, or your findings, especially if you have lots of interactions happening, lots of exploratory analysis and these kind of things?
Yeah, I think that's a great question and a challenge, because there are so many conflicting interests in terms of time to create these tools and time to engage with the experts, and reproducibility is perhaps the last of the concerns when thinking of building visualizations and tools and systems. And I think one way to increase reproducibility is facilitating, creating the technical framework to facilitate the creation of more reproducible tools and systems. And that's ongoing work by the community and many research groups.
I would like to
Ameya,
add
do you?
yeah. So I guess reproducibility, interactive visualizations kind of helps solve the reproducibility issue, because it's just the data that's probably changing. The interface remains the same, more or less. So anyone who tries to access the interface, the dashboard, they are bound to get the correct visualizations unless the data is not lying. So I guess interactivity in itself is one step towards making things reproducible, towards making research reproducible. So instead of just publishing plots for your paper, for your research, if you just provide them the link to the dashboard from where you created those visualizations, it's a good way of making sure reproducibility is ensured in the process. That's my thought. Yeah.
Thank you both. I think we're at the end of the session. Thank you, everyone. Thanks to the speakers. Thanks to those who discuss. Take the time to follow up with everyone after the session. Thanks again. And we're handing over to our last topic on people, art, and engagement. Over to you, Eleni.